For this lesson, we're going to be looking at slope, and slope is simply the steepness of a line. Mathematically, it's the ratio of the rise, which would be how far you went vertically or up or down, versus the run, how far you changed horizontally. So how far across you went. So if you went up a bit and across a bit, the slope would be the ratio of that, or the steepness of that line. So here's the definition. Slope equals rise, how far you went up or down, divided by the run, how far you went across. The rise is going to be considered positive if we're counting upwards, and negative if we're counting downwards. Whereas the run is positive if we're going to the right, and negative if we're going to the left. And finally, just note that the slope is written as a reduced fraction. So let's say you had a rise of 3 and a run of 6. We would write that down as the reduced fraction of 1/2. So let's look at a few examples. There's 5 lines on this graph, and we're going to determine the slope of each of them. And remember, the slope is the steepness of the line. It equals the rise divided by the run. So if we look at line 1, if you think of us going from this point on the left to this point on the right, how far did you have to travel? Well, you went 1, 2, 3, 4, 5 across, and 1, 2, 3, 4, 5 up. So for line 1, you had a rise of 5, you went 5 up, divided by a run of 5, you went 5 across. 5 divided by 5 is 1. Looking at line 2, start from the left and you're going all the way to the right. If you do so, you're going across 1, 2, 3, 4, 5. So you're going 5 across, but you're not going up or down. Your run in this case is 0. So your slope would be a run of 0 divided by a rise, your slope would be a rise of 0 divided by a run of 5, which just equals 0. For line 3, start from this point on the left, go to this point on the right, and you're going across 1, 2, 3 times, and you're going up 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So for line 3, your rise is 9. We divide that by the run of 3. 9 divided by 3 is 3. Let's look at line 4 a little more closely. With lines 1 to 3, we were looking at the slope going from the first point on one end to the second point on another end. But if you notice with line 4, you're not at an exact value, right? And by exact value, I mean a point that is exactly on a crosshair like that. So for line 4, what I would suggest is, instead of counting from end to end, I would go from this point, because it's right between the marks there, to this point up here. Again, it's right between the marks, so you can get an exact value. And if we look from the 2 purple points, how far are we going across? Once, twice, so 2 times across. How far are we going up? We're going up once. So when we're looking at line 4, we can say for line 4, we have a rise of 1, and we divide that by a run of 2. So that's our slope. 1/2, that's already a reduced fraction. Same story with line 5. Instead of going from this point to this point, since those are, unexact readings on the graph, I would instead choose these 2 points, here and here, because we can get those exact values. So going from left to right, we travel 1, 2, 3 times across, and once, twice up. So for line 5, our slope is the rise of 2 divided by the run of 3. And that's already a reduced fraction. And just a quick point here, if you wanted to, you can look at your line from the right to the left. I think it's good practice to go from left to right, but if you wanted to, you can go from the right to the left. So let's say this is our first point here. I'm going to color it in green, and we're going to go down to the second point in green. So we would have gone down 2, that would be a rise of -2, and we would have gone left 3 times, that would be a run of -3. So if you're looking at the slope in this way, you'll have a rise of -2, a run of -3, and the negatives cancel out, you'll still have a slope of 2/3, which was the same as you calculated when you're going left to right, and it should be the same. Remember, slope is simply a measure of the steepness of a line. The line is as steep as it is, no matter if you're looking at it from left to right or right to left. That shouldn't change how steep the line is. Some more examples. Another graph. Notice that these are pointing downward. We have one vertical line over here. Let's see how that changes our values. So looking at line 1, if we're going from left to right, we are going down 1, 2, 3, 4, 5, 6, 7, 8. We're going down 8 times, so our rise is a -8. Remember, downward direction is negative. We're going across 1, 2, 3, 4 times. So for line 1, our slope is -8 divided by 4, which reduces to -2. Looking at line 2, this one's very steep. We're going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're going down 16, so that's a rise of -16, and we're going across 1, 2, 3, 4 times. So for line 2, we have a rise of -16, which means we're falling, and we're going to the right 4 times. -16/4 would reduce to -4. Line 3 now. Notice that line 3, you can say it goes up, you can say it goes down. Same thing, we can say we have a rise of 1, 2, 3, 4, 5, but there's no run. It doesn't go across at all. So since there's no run, it's not going across, let's take a look at that slope. A rise of 5, but a run of nothing, a run of 0. And you can't divide by 0. What we say is that is undefined. Undefined because we cannot divide by 0. Finally, let's look at line 4. We don't have an exact value over there, so we can choose to go from this point to, say, this point here. And if we do so, we're going down 1, 2, 3, 4, 5 times. So we're falling 5, or we have a rise of -5. And we're going to the right 1, 2, 3, 4 times. So for line 4, our slope would be -5/4, which is already reduced as a fraction. Oh, we actually have one more, line 5. We can go from this point here to this point here. We're going down 1, so a rise of -1, and we're going 1, 2, 3 to the right. So for line 5, a rise of -1, a run of 3. And just a quick note, you can write your slope like this, where you have a -1/3, or it's the same thing as saying it's -1 divided by 3. It's the same. Okay, let's sum this up. If you have a line with a positive slope, that means you're going up like this. That means you rise as you look from the left to the right. Lines with negative slopes, which look like this, means you fall. If you have a negative slope, your line is falling as you look from the left to the right. Vertical lines have no run. Therefore, you're dividing by 0, which we can't do. We say that is undefined. Whereas horizontal lines just go straight across. There's no rise. So the rise is 0, therefore the slope is 0. So horizontal lines have a slope of 0. Okay, let's look at drawing lines using a slope. So we're going to draw a line segment with each given slope. And notice we have m equals 7 over 5, m equals -3, m equals 0. The symbol m means slope, okay? So m is slope. If we want to draw a line segment with a given slope, we need a starting point. Choose any starting point you want. For A, for instance, I can choose this as my starting point. And if my slope is 7 over 5, that means I'll just count up 7. 1, 2, 3, 4, 5, 6, 7. I count across 5. 1, 2, 3, 4, 5. So my second point, if I'm starting here as my first point, my second point should be across 5 and up 7, which is there. And then I can just draw that line. For B, remember slope is rise over run. If you just have a number like -3, if it helps, you can write that as -3 over 1. So let's just choose this right here as our starting point for line segment B. And we're told to go down 3, -3, so down 3, 1, 2, 3, and across 1. Here's across 1. So that would be our line segment. Finally, line C is a slope of 0. Slope of 0 means horizontal line. So whatever starting point I have, let me put a starting point there, I know that I have no rise. I'm just doing a straight horizontal line. That could be a line segment right there. So how about determining the slope between 2 points? So let's determine the slope of a line that passes through point 1, which is 3, 4, and point 2, 6, 9. So for point 1, we know the x value of point 1 is 3, and the y value of point 1 is 4. Plotting that on the graph, 3 and then 4, point A sits, or point 1 sits there. Okay, how about point 2? Point 2 is has an x value of 6. So point 2's x value is 6, and point 2's y value is 9. So 6 for x, 9 for y. That's point 2 right there. And you want to determine the slope of a line that passes through those 2 points. So we know slope equals rise over run. The run in this case is 1, 2, 3. The rise is 1, 2, 3, 4, 5. So your slope is 5 over 3. But what if we weren't able to count so easily? If these numbers weren't so clean and exact? There's another method to calculate slope. So slope is always rise over run. It's the steepness of the line. But let's now try to calculate the rise, not count for it, and calculate the run, instead of count for it. Now we know the y value, or how high point 2 is. So the y value of point 2 we know is 9. And we know the y value of point 1 is 4. For slope we want the rise, so we have to figure out what the rise is. What's the distance between y2 and y1 here? And can you see that that blue distance is just 9 take away 4, or 9 minus 4. So your rise in this case is 9 minus 4. And let's do the same for run. I'm going to clear this part out. just so it's not too much mess on the graph. So point 2 goes all the way from the y-axis to a x value 0.2 of 6. Point 1 has an x value of 3. What we want to figure out is, what's this run? Well, that run is going to be 6 take away 3, or 6 minus 3. So your run is 6 minus 3. So your run is 9 minus 4, which is 5, divided by 6 minus 3, which is 3. So that's another method to calculate slope. If you're not counting, or if you can't count for slope, you can calculate the slope by calculating the rise, dividing that by the run. In general, the formula for slope is going to equal the y value of point number 2 minus the y value of point number 1, that is your rise, divided by the x value of point number 2 minus the x value of point number 1. That would be your run. Now here's a couple of examples in using this formula. So the formula is rise over run, the y value of your second point minus the y value of your first point, divided by the x value of your second point minus the x value of your first point. Now, it doesn't matter which point you say is your first or your second, you just have to be consistent with your labeling. And I'll show you what I mean. Let's say point C is point number 1, D is going to be my point number 2. If I'm using the slope formula, it's always helpful to write the formula down first. And then fill out the formula. So, y2, it's your y value of your second point, that's negative 4, minus y1, which is your y value of your first point. Divide that by your x value of your second point, 5, minus the x value of your first point, 0. So you'll have negative 4 minus 3, which is negative 7, divided by 5 minus 0, which is 5. So your slope would be negative 7 over 5. Now, if you wanted to, you could have made D your first point and C your second point. And then 0 would be x2, 3 would be y2, 5 would be x1, and 4 would be your y1. And we should still get the same result. So slope equals y2, which now is 3, minus y1, which is negative 4. We'll divide that by the x value of point 2, which is 0, minus the x value of point 1, which is 5. So here we have 3 minus a negative 4. That's like 3 plus 4, which is a positive 7. 0 minus 5, which is a negative 5. That's equal to 7 over negative 5. Generally, when we have a negative in a fraction, we'll write it on the top line or on the outside of the fraction. So you can see that that is the same result, which makes sense because slope is a measure of steepness. Shouldn't matter how you calculate the steepness, the line is as steep as it is. Okay, let's look at point B, or problem B. We have point E is 200 and 150, F is 400 and negative 500. So if E is point number 1, then this will be x1 and this will be y1. If F is point number 2, then this would be x2 and this would be y2. And all we have to do at this point is write our formula and fill in the numbers. y2 is the negative 500. y1, which we're subtracting, is 150. Divide that by x2, which is 400. And we'll subtract from that x1, which is 200. Negative 500 minus 150 is a negative 650. 400 minus 200 is 200. As a reduced fraction, that would be negative 13 over 4.